Hello everybody and welcome to the 9.7 notes over special right triangles. And so the main goal for today is, again, this entire chapter is about learning more about right triangles than you ever thought you ever would. So to add on to that, special right triangles mean specifically 30, 60, 90 triangles. So if your triangle has a 90-degree angle, a 30-degree angle, and a 60-degree angle, or a 90-degree angle, 45 and 45-degree angles. And so what I'd like to do first is have you pause the video, just like we did for proving all the Pythagorean triples. I would like you to do the Pythagorean theorem on all three of these triangles and find your third side and take a look to see if you can find a pattern in your triangles. So if you could please pause your video now, I'd like you to please do the Pythags, and then we will come back and look at a relationship. All right, please pause now. Okay guys, so if you could check your work please. For the first one, I got my third side to be 8. Please make sure in all three examples, when you squared something like 4 root 3, that you squared both the 4 and got 16, and then multiplied that by root 3 squared, which is 3. So this should be 48. So for the first one, my answer was 8 for the hypotenuse. My shortest leg here was 2 for the second example, and then the third example, I got the shortest leg here to be 3. But here's what I really want you to look at. If we take a look at this first triangle, I notice that the shortest side is across from the smallest angle. The medium side, 4 times root 3, is smaller than 8, and it's across from the second largest angle. And the biggest side of 8 is across from the largest angle of 90. And I notice that in all three examples, the smallest side is always just the smallest number. And then the medium side, in all three cases, is root 3 bigger than the smallest side. That this side is 3 times root 3, when the original side was 3, or the smallest side. This was 2 times root 3, when the original smallest side was 2. When the smallest side was 4, the medium side was 4 root 3. Interesting. I also notice across the board that my hypotenuse, which I'm circling here in yellow, is always double the smallest side. 3 times 2 is 6. 2 times 2 is 4. 4 times 2 is 8. So if I had to draw a 30, 60, 90 triangle, a basic looking one, let me actually make it a little bit more accurate with what we were just doing. I'm going to draw a triangle where the 30-degree angle is on the top and is across from the smallest side. The 60-degree angle is across from the medium side, and the right angle is across from the largest hypotenuse. So based on my previous 3 triangles, let me call my smallest side x. Let me call the medium side that it's root 3 larger than the smallest side. So that can be represented as x times root 3. And then my hypotenuse, circled in yellow, was 2 times as big as the smallest side, which we could represent as 2x. So if I thought about writing these in terms of equations, you could say that your hypotenuse is 2 times your short leg. You could say that your longer leg, and because you remember in a right triangle we have the hypotenuse here, we have the 2 legs, but this would be called the short leg, which I will abbreviate SL, and this will be the longer leg, which I will abbreviate as LL. The longer leg is the shorter leg times root 3. So notice in both circumstances that everything depends on the short leg. So I'm going to write a little note. Everything depends on the short leg. So if I have a 30, 60, 90 triangle, if I know what my short leg is, I can find the hypotenuse in the longer leg very quickly. Another thing to point out to you is that I could switch the way this triangle looks and the relationship would still be true. So if I drew it like this instead, and this time I had the 30-degree angle down here, the 60 here, and this is 90, my relationship would be the same. The smallest side would still go with my smallest angle, and that would be x. My medium side would still be root 3 times as big as the short, and my hypotenuse would still be 2 times as big as the short. So it doesn't matter which way you orient your triangle, the relationship is still true. we'll be applying this very soon. The next example, the 45, 45, 90, I again would like you to do the Pythagorean theorem. But first, I'd like you to notice that in a 45, 45, 90 triangle, notice that these two angles are the same. And from first semester, we know if two angles are congruent, then the two sides have to be congruent as well. So I know that these legs have to be equal, so this is also 6. And I know that these two legs have to be equal, so this also has to be x. So what I would like you to do is, again, pause your video. Please do the Pythagorean theorem to find this hypotenuse and see if you can find this side, and then let's see if we can find any relationships. All right, so please pause now. All right, guys, so here's my Pythagorean theorem work. On the first triangle, I got that the hypotenuse was 6 root 2, so my triangle was leg 6, hypotenuse 6 root 2. And when I did the Pythagorean theorem here, just make sure that when you had x squared plus x squared, you got 2x squared on this side, and 7 root 2 squared is really 49 times 2, which is 98. So when I divided by 2 and took the square root, I got that my side was 7. So I had 7 root 2. So if I'm interested again in drawing a relationship in my triangle, if I happen to have a triangle that's a 45, 45, 90, notice that my legs in both cases have to be the same. So if I was going to be general, both legs would have to be x. And also in both cases, my hypotenuse was root 2 larger than the leg. So I could symbolize that as x root 2. So in an equation form, you could say that your hypotenuse is your leg times root 2. And that's the only equation. Because if you had the hypotenuse and you wanted to find the leg, you could divide by root 2. If you have a leg and want to find the hypotenuse, you could multiply by root 2. And again, it doesn't matter how you orient this triangle. What matters is this relationship that my legs are congruent and my hypotenuse is root 2 larger. So if I look at some examples, I would like to focus first on the 30, 60, 90 triangles. And so I'm going to draw the general 30, 60, 90 relationship here, 30, 60, 90. Recall from earlier that the shortest side across from the 30 is always my smallest and what everything depends on. My medium side, or longer leg, was x root 3. My hypotenuse was 2 times as big as the short leg. The reason I want to start with this example here is notice that I did give you the short leg. The 8 is the shortest one, and everything depends on x. So without much work, what you could do is say that my medium side, or my longer leg, is 8 times root 3, and then my hypotenuse is 2 times the shortest side of 8, or 16. So without much work, I know that my longer leg is 8 root 3, and my hypotenuse is 16. The other way, though, if we looked at the first example, I have a 30, 60, 90 triangle again, but this time I gave you the longer leg, which means I gave you this side here, the x root 3. And remember I mentioned earlier that everything depends on my shortest side. So if I can find this side, then I can find my hypotenuse very quickly. So if I'm giving you 2 root 3, that means that to get from the medium side to the short, I have to get rid of the root 3. So I'd have to take 2 root 3 and divide by root 3 to get from here to here. When I divide root 3 divided by root 3, they cross out. And so that means that my shortest leg is 2, which means even more that my hypotenuse has to be 2 times as big as the shorter leg, or 4. In the 45, 45, 90 triangles here, if I start with maybe this example down here, I know that in a 45, 45, 90, my legs are congruent. So this side automatically is going to be 8 root 2. But my hypotenuse, based on the previous page here, my hypotenuse is root 2 bigger than my leg. So if I take the 8 root 2 and I multiply by root 2, that would be 8 root 4, which is really 8 times 2, or 16. This example, I'm given the hypotenuse. And based on, again, excuse my going back, but based on my previous slide here, I have my x root 2. So if I want to get from x root 2 back to the leg, I need to divide by root 2. So if I would like to find both legs at the same time, I can take 10 root 2 divided by root 2. These would cancel. So I would get that both legs would be 10. Even more examples. Here is another 30, 60, 90. And again, I gave you the longer leg of 6. So it says LL. The weird thing this time, though, is if I want to find my short side, I know that this side is really x root 3, and this side is really x. So just like one previous example, to get from here to here, I have to divide by root 3. But this time, if I do 6 divided by root 3, as we discussed in an earlier video, I can't leave a radical in the denominator. So what we have to do is rationalize. We need to multiply top and bottom by root 3, and if I do that, I would get 6 root 3 in the numerator. In the denominator, I'd get root 3 times root 3, which is root 9, which is really 3. And then I notice that 6 divided by 3 here can be reduced, so this actually ends up being 2 root 3. So my short leg ends up being 2 root 3, which means that my hypotenuse has to double that, so my hypotenuse has to be 4 root 3. If I stick with the 30, 60, 90 and I look down here, I notice this time that I gave you the hypotenuse of 6 root 3. Now, remember, in a 30, 60, 90 triangle, I'll orient it the same way. We have x, x root 3, and 2x. This time I've given you 2x, and we need to get to the shortest side of x. So we need to take 6 root 3 and divide that by 2 this time to get from here to here. If I take 6 root 3 divided by 2, I get this side to be 3 root 3. And then, to get the longer leg, I know that the longer leg is root 3 bigger than the smallest. So what we'd have to do is take my shortest leg, which is 3 root 3, and then multiply that by root 3. So I get 3 times root 9, which is 3 times 3, or just the number 9. If I look at this 45, 45, 90 triangle, 45, 45 implies that the legs are congruent, so this is also 3 root 6. And if I want to get my hypotenuse, the 45, 45, 90 triangle is x, x, x root 2. So this side is root 2 larger than what I have now. So I take 3 root 6, multiply that by root 2. I would get 3 root 12, because these are kind of like terms. I would then take root 12 and split that into 4 times 3. So that would be 3 times 2 root 3, or 6 root 3. So your hypotenuse is 6 root 3. This example, I am again given a 45, 45, 90 triangle, but this time, oddly, I'm not given something with root 2, I'm given something with root 3. But nonetheless, I know that my relationship is that I gave you this side. And if we want to get from here to here, we have to divide by root 2. So I would take my 3 root 3 and I would divide that by root 2. Unfortunately, we would have to rationalize again. We'd have to multiply top and bottom by root 2, so this isn't in the denominator anymore. And if I did that, the numerator I'd get 3 root 6, and the denominator I would get root 4, which is really 2. So I'd get 3 root 6 over 2. Now, I can't reduce 3 and 2, so I'd have both of my legs to be 3 root 6 over 2. So, next, I left some space for you in your notes for you to try some of these on your own, and I'll have the answers when you get back. So if you could, take a minute and write down the examples 1 to 6. If you could pause your video now and write these down. I have a couple more in the next slide as well, so please pause now. When you're done writing those first 6 done, here are 2 more examples, 7 and 8, that your goal is to find the other 2 sides given the 30, 60, 90s. So please write these down as well. And so what I'm going to do is the next video, I am going to do numbers 1 to 6 as well as 7 and 8, but I'd like you to try them first. We will also talk about these 2 examples. I think it is good for you to try these before we go through them. So I will see you at the next video, and thank you for your effort.